This video gives us an introduction to polar coordinates. In rectangular coordinate system, a point in the plane is represented by an ordered pair of numbers x, y, where x and y equal the signed distance of the point from the x or the y axis. In a polar coordinate system, we select a point called the pole. So right here, there's our pole. Then a ray with a vertex at the pole called the polar axis. So that's the red one here. The polar axis is usually drawn in the direction of the positive x-axis, and the pole coincides with the origin. So just kind of to tie rectangular and polar together. A point P in polar coordinates, so here's our point P right here, is represented by an ordered pair of numbers r, theta. Instead of xy, it's r theta. The number r is the distance of the point from the pole, so whatever this distance is, and then the theta is the angle in, it could be degrees, it could be in radian, that's formed by the polar axis and this ray. So right there's our theta. So here's where things get a little bit weird though. If your r value is positive, then the point P lies on the terminal side of theta. So you're going to actually find your angle theta first. And if your P is positive, you're going to go in the direction of theta. But if r is negative, then the point P lies on the ray pointing in the opposite direction of the terminal side of theta, a distance of absolute value of r from the pole. So if your r value is negative, you're going to find your theta, but instead of going towards theta, you're going to go in the opposite direction and plot your point. And if r is actually 0, then your point lies right on top of the pole. So let's plot some points in the polar coordinate system. We'll start by plotting 6, 30 degrees. So you actually want to go to your degree first. So we'll find 30 degrees, and this is what our polar graph paper looks like this bullseye here. Now be careful because sometimes the angles are exactly the unit circle ones and sometimes there's more, so just make sure you're looking and getting the correct angle measure. All right, so there's 30 degrees for us. Now our r value is positive, so we're going to go 6 rings out in the same direction as that angle. So starting at our pole, we're going to go 1, 2, 3, 4, 5, 6 rings out, and there's our point. That highlight, that's actually not part of it. That was just to help us find where to go. So find your angle. If your r is positive, you're going to go that many rings towards your angle. If your r is negative, we're going to go in the opposite direction. So let's look at one where we're in radian and our r value is negative. Well, we start with our angle, which is 7 pi over 4. So that's down here in our fourth quadrant. Now we look at our r value, it is negative, so instead of going in the direction of our highlight, which is our angle, we're going to go in the opposite direction and we're going 4 rings. And there's our point in what looks like the second quadrant. One important difference between rectangular coordinates and polar coordinates is that while a given point in the plane can only have one pair of rectangular coordinates, this same point can have an infinite number of pairs of polar coordinates. And that's because of coterminal angles, because we could just go round and round and round forever with coterminal angles. So for example, 240 degrees locates the same point as 600 degrees, or 960 degrees, or negative 120 degrees.